think I'm recording. I hope I'm recording. The first time I wasn't recording, and so we're going to try it again. It says, what is the domain? And they've given you a set of ordered pairs. And so the elements for X, that's what the domain is, the elements for X. And so I'm going to put my set bracket. So it's the set, that's what the domain is, it's a set. And the items that it has in it are -2, +2, and 3. And you normally would put those in numerical order. It doesn't have anything else besides these 3 items. What is the range? Those are the outputs, which are 6 and 1. Those are the Y values. And there's just 2 of them. You wouldn't write the 6 twice. You would just write it once. 1, 6. You would write it normally in numerical order. Then it's asking you, is this relation a function? And you could do a function map. So here's the domain. It had -2 in it, 2 in it, and 3. That was a 2. My little function map. It has my domain. It has -2, 2, and 3. My range, 1 and 6. -2 maps to 6. That's fine. 2 maps to 6. That's fine. Each one of these elements can only map to one thing. 3 maps to 1. It's great. And so is it a function? Yes. If there had been one more ordered pair in this set, which there's only 3, but if there had been, so this is a what if. What if? I know it wasn't asking us to do this, but just what if. What if there was another ordered pair? So there was the same ordered pairs there already was, and then there was this one more ordered pair, and that ordered pair was 3, 2. And so would it then be a function? And so when we came up here, we'd have to put 2 over here, right? And 3 would map to 2, because we'd have one more thing. And then it would be, then the answer would be no. It's not a function because 3 is mapping to 2 things. So the way it was okay. So if you're thinking, well, isn't 6 mapping to 2 things? I'm erasing that. My what if is going away. But it is okay for more than one input to map to a single output. What's not okay is for an input to map to 2 different inputs. Then here it's asking us to state which of the following represents the graph of a function. All functions that when you draw a vertical line, you hit the graph only one time because each input goes with exactly one output. And you can see that I'm going to hit it only one time on B. So this one is, yes, it's a function. State whether each of the graph represents a function. So maybe the answer is just, it's a function. Wasn't a yes or no, huh? It's a function. I wonder if that's the same as when you go down to the hospital and have a baby and they tell you about your baby. So it's a function here. Each vertical line is just going to hit the graph one time, right? So it's a function. Why I did B before I did A, I don't know. Doesn't matter, right? Independent of one another. Hits twice. So not a function. Here it says graph y equals x squared minus 2. Find the domain and the range and indicate whether the graph is the graph of a function. So I have my Susie's meowing at me. She says, is it dinner time? So if x is 0, then 0 squared minus 2, y is -2. 1, then 1 squared minus 2 is -1. 2, 2 squared minus 2 is +2. 3, 3 squared minus 2. 9 take away 2 is 7, right? And I also want to get some that are negative when I square them, like -1. So -1 squared is +1, and then -2 is -1. And -2, when you square that, -2 squared, that's 4. Remember, it's this. So if you're saying, wait a minute, remember, it's this, -2. So if you're saying, where did the parentheses come from? Parentheses are there when you replace. So there, it's assumed that the parentheses would be there. So this is 4 minus 2 is 2. If I put in -3, -3 squared is 9. 9 take away 2 is 7, so etc. So I'm going to plot these points over 0 down 2, over 1 down 1, over 2 up 2, over 3 up 7, -1 1, and -2 2. You can see the symmetry. -3 7. And so it's supposed to make, when it has x to the second, it's supposed to make something that looks like a parabola. And it's kind of a curved figure. Like that. So what is the domain? That's the values that I could stick in for x. And I can put in any value for x and I'll find a y value. It won't go undefined or anything like that. So even if I put in -10, not that I want to graph it, but it will be there. -10 squared is 100, take away 2 is 98, right? And so I could come over here, -10, here's -10 right over here somewhere, and I could go up 98, and there it would be up. You can see that it's going up there very slowly. It's going to take to get over there. And so the domain could be any real number. All real numbers is what we say. And I said that it was okay to use this symbol if you wanted. And then the range, well, looking at these values over here, is there ever a place where they don't go any lower? And you notice that -2 is the very lowest that it goes. All of these are higher than -2. And I look on this graph and I see that -2 is the lowest that it goes for the y value, and it doesn't go any lower than that. So the range is such that y is greater than or equal to -2, and in fancy notation, the set of y such that y is greater than or equal to -2. And is it a function? Well, imagine your vertical lines, only hit it once, and so yes, it's a function. Okay, so we did a lovely job on that. This was infinitely many ordered pairs, right? So whereas here we found the domain with just 3 ordered pairs. Now we have a function f that has 1, 2, 3, 4, 5 ordered pairs on it, and a function g that has infinitely many ordered pairs, but some of them are nice. This one right here is an ordered pair and has x value and a y value that go with one another. And right here is another one, but they're not nice. But the others are pretty nice on it. And then h, there's infinitely many values that we can choose for h here. And so this will create infinitely many ordered pairs. And k, the only thing that we wouldn't be allowed to choose for x would be things that make the domain, that make the denominator 0, because those wouldn't be in the domain, right? And the same for j. We can't choose things that are not in the denominator. Values of x that make the denominator 0 are not allowed. And then the m, any value that I plug in is going to be okay because there's no denominator. So any value you tell me to choose for x, I will be able to find out what y is, right? So f plus g at 2, by the definition, this is f at 2 plus g at 2. And f at 2 is 4, right? The input is 2, the output is 4, so this is 4. G at 2, so I'm going to go over here to 2, the output is 0. This is the ordered pair 2, 0, right? And so 0 plus 0, g at 2 is 0. So f plus g at 2 is 4. H minus m, and this is shortcut notation for this. They haven't told us at x, and if they don't tell you at x, they mean at x, which is equal to h, by definition, at x, minus m at x. And whenever you replace binomials in, for sure, parentheses are implied. It's a good idea to use parentheses, most always anyway, probably. So here I'm going to definitely need parentheses because I can see that m is a binomial. M at x is 3x minus 8. And because this is a minus, I'm going to need to distribute that negative. And h of x is 2x squared minus 1. So I'm going to distribute my, so I'm going to have here 2x squared minus 1. I'm going to distribute my negative. So I'm going to get negative 3x plus 8. Then I'm going to collect like terms, and put it in order. 2x squared minus 3x plus 7. And then I'm all done. And so this is h minus m at x, is this right here. J at 2 plus k at 3. So it's asking me to go to the function called j and put in 2 for the x, right? So I'm going to be kind of on my side piece of paper here since I'm going to have to work on it a little bit. Maybe I'll just make a little indentation over here, right? J at 2 is equal to the blank, what was it, plus 1, divided by 6 times the blank. And what are we putting in the blank? 2. So this is 3 over 12, which is 1/4, right? So j at 2 is 1/4 plus, and then k at 3, so I'm going to find that, k at 3. So let's see what k says. K is this function, so it's 3 times the blank, and then squared minus 3 times it, and then plus 4. Okay. So, and we're going to put into the blank 3. So in the numerator we get 9, and in the denominator we get, that's 0, right? 9, take away 9 is 0, plus 4, so 4. So 4/9. So, whoops, 9/4. Sorry, I said that upside down. And so when we add these together, that's 10/4. I hope that I don't make a bad joke like 10/4, good buddy, or something like that, right? And then 2 goes into both, so this is 5 over 2. So we did a lovely job on that. H at negative 3. Okay, so H is 2 times the blank squared minus 1. They're asking us to put in negative 3. Substitute it in. If you don't use parentheses, then you get the wrong answer about half the time. And so this is 9 times 2 is 18. Take away 1, which is 17. And I wish I would have brought a calculator here. I'm doing everything by hand, but you can check it with your calculator and send me an email if you think I goofed up. Okay, same functions. Here it's asking me find m at x minus m at a divided by x minus a. So we're going to have, I don't know, parentheses or box minus box here over x minus a. And we're going to put in x, right? Think of it as a blank. And when you put in x, well, that's what you had originally. So that's just 3x minus 8 in here. These are really parentheses. And I want to subtract this, really parentheses. I'm trying to keep them separated at a. So this is 3a minus 8. So I have to distribute the negative. So this is 3x minus 8 minus 3a plus 8 over x minus a. And the 8's reduce out, make 0, and I get 3x minus 3a over x minus a. And then I try to reduce this. It's a binomial divided by a binomial, and it will reduce if the top will factor or the bottom will factor or both will factor. And really the top factors, it's got a greatest common factor of 3, x minus a, over the bottom doesn't factor, so I just put x minus a. Those are the same. So they simplify out and I get 3. So no matter what you put in here, whenever you do that, and whatever value that you put in, you will always get 3 for x or for a. Find the range of g. And so the range of g, remember, is the y values. So how low does it go? So I'm looking, this is the lowest point, and that's there at -3. And everything in between is taken care of all the way to the highest point, and the highest point is at 4. So the range is all the values between -3 and 4. That's the lowest it goes, that's the highest it goes. So the range is the values of y such that y was between -3 and 4. Okay, so there's the range. F composed with g by definition is f at g at 1. And g at 1, I have to look that up on my graph. So at 1, I'm up here at 4. So g at 1 is equal to 4. And so I'm going to go here and I'm going to put in g of 1 is equal to 4. So then now it's asking me about f at 4. And f at 4, I'm looking for an input that's 4. -2, 3, 4. There it is, 16. So the output there is 16. So f composed with g at 1 is equal to 16. Okay, so we did a good job. We're on number 10. Asking us to state the domain of this function. And all values are okay except for where the denominator is equal to 0. And so what would not be allowed, not allowed, is for the denominator to equal 0. That's what not be allowed. And the good news is x squared minus 3x minus 4 equals 0 is something I learned to solve and find the values of x that go with that. Excuse me, from, I don't remember which chapter 5, I think chapter 5, I learned to solve that. So they said that if it's quadratic and you're trying to solve, get 0 on one side. Well, I got it, great. Then they say that you would want to get it factored, and it's a trinomial, and to make 4 is 4 times 1, and it's got to subtract to be 3. Yes, it does. It's got to be -4 and plus 1. So this is x minus 4, x plus 1 equals 0. And then I would set the pieces, I'm out of room here, and so set the pieces, x minus 4 equals 0. So adding 4 to both sides gives us x is 4. But remember, that was not allowed. This is what I wanted not to be allowed. And x plus 1 equals 0. Taking away 1. Remember, this is not allowed. So when I write my domain is the set of x's such that x is not 4 and x is not -1. So I want to exclude those values. So I put the not equals on them to exclude them. And we did a lovely job on that. They're asking us to simplify this. How you simplify something is that you factor the top and you factor the bottom. So if you have 4 terms, you factor. If you have 3 terms, you factor if you're simplifying. And if you have 2 terms, you factor. And I have 4 terms and 2 terms. And so I'm on my, my factoring area down here so that I can get it factored, because it's going to maybe be more than one step to get it factored. So I'm trying to factor this, and I notice that it's in descending order. It's got 4 terms, but it does not have a greatest common factor for all 4 terms. So I group the first 2, and they have in common x squared. And I group the second 2, you bring down this sign, and I group these, and they have in common 3, x plus 3. If these binomials are not the same, then you've made a mistake, but they are the same here. So you factor out the greatest common factor binomial, which is x plus 3, and I get x squared plus 3. Then you look at your pieces. Will this factor further? No. Will this factor further? No, it won't. It won't factor further because it is not a greatest common factor, a difference of squares, or a cube. Those are what you have choices of for it to factor if it's a binomial, and it's none of those things. And so this is all done. This factored into a binomial times a binomial. And then this right here, you could factor it as well. Now I would be tempted just to say, okay, this is a cube, right? X cubed and 3 cubed. So, and you could sing your song, or you could do it however you do it, you know, you could use the formula, but it is a formula. And so if you're singing, sing along with me, finger over 3's, write what you see, square, multiply, square, soap. So if you're a singer, you're singing along with me, and if you're not a singer, then you're using the formula or whatever. And x plus 3 and x plus 3 are the same, so you can simplify them out, and my answer then is just x squared plus 3 divided by, and no parentheses needed, x squared minus 3x plus 9. This is a binomial, that's a trinomial. They're not even the same size, so they can't reduce with one another for sure. And I'm going to get some more factoring on here. So this is problem 13. And I'm supposed to multiply that. So in order to multiply that, you got to factor all of the pieces. So I've got monomials, binomials, and trinomial. So you start with whatever makes you happy on factoring. This is a difference of squares. So that factors as x plus 7, x minus 7 times. This is a greatest common factor of x. X times x minus 7. This down here is a trinomial. Trying to think of things that multiply together to give 70. Doesn't have a greatest common factor, but when I subtract them, I get 3. So I know the numbers are kind of close together, like 7 and 10 maybe. And let's see, one's positive and one's negative. I think the 7's negative and the 10 is positive. And x minus 7, x plus 10. And last I have my monomial, and I would do my monomial last. And I see I have a monomial x here, so I'm going to go ahead and write x as x times x. So that when I cancel things, monomials first, an x will cancel with an x. It'll reduce out. It doesn't matter which one I color out. It's x divided by x is 1, is what I have going there. And then x minus 7 divided by x minus 7, well, that's 1 as well. So you notice they can be top and bottom, or they can be catty corner. This won't reduce with either one of those because they're not even the same size. These are binomials, and so it won't reduce with this monomial. And this is not the same as those. So what I have is a binomial, x plus 7, x minus 7, times a monomial, x times x plus 10. And then I have a divide. So first thing I got to do is write it as a multiply. And so anytime that you have a division, you're going to rewrite it as a multiply, and then you're going to use the rules for a multiplication. So I'm rewriting it as a multiplication, and then I'm going to factor all of the pieces. So I always start with binomials and then go to trinomials and then go do fourth term things and then go to monomials if you have them. And so x to the third minus 8, I notice, oh, that's a cube, right? 8 is 2 to the third. So however you factor it, you could factor it on your side piece of paper or you could sing your song. If you needed to, you could write it here so that you could see the base. It's 2. Whatever, it doesn't, you know, all of this is good. So x minus 2, square it, x squared, multiply them together, 2x, square it, 4, soap, positive, positive. And, okay, so I got that one factored. And over, and I can't help but notice, and I hope that you can't help but notice that this one that's down here is the same as that one, right? So I know that that one won't factor, and even if it would, they're the same. They'll cancel with one another because a trinomial will cancel with a trinomial if it's exactly the same. So that only leaves me 2 more things to factor. So I'm working on getting them factored, and they're my least favorite to factor. And I use trial and error. I use guess and check. I use unfoil, whatever you want to call it. These are all methods, names for the same darn method, different names for the same darn method. But I'm thinking, okay, to make the first would be x times 2x. To make 15 could be 1 and 15. It could be 3 and 5. I'll decide in a second. The signs are 1 positive, 1 negative. I'll decide in a second. So I'm going to fit in here what I think it's going to be. It's going to subtract together to give 1 in the center. So I'm thinking to myself, I just want a difference of 1 of my things, of my outer and my inner. So if you're saying, what are your things? Well, it's my outer and my inner. And so I can make, I put a 3 here, I can make 6x squared, 6x, not x squared, just 6x. And I can make 5 right here, 5x. And you can see that I have a difference of 1. And so that's what I was wanting, was a difference of 1. Now I wanted the 6 to be positive and the 5 to be negative. So I'm going to have a plus here and a minus here. And I want to make sure, you know, am I going to get negative 15? Yeah, I am, negative 15. Am I going to get x squared, 2x squared? Yeah, I'm going to get that. And then I'm going to get positive x. So let's see, that one with the 15, the one with the 15 was here, so it's going to go here. X plus 3, 2x minus 5. And then I want to factor the other one. One and 10. Signs are the same, both negative, 2 and 5. And I want to make 9 when I subtract them. No, when I add them. When I add them, right? So x and 2x. And when I add them, I want to make 9. Oh, if I put a 2 here, I'll get a 4, right? Remember, their signs are both negative. If I put a 5 here, so on the inner here, I'll get negative 4x. And here on the outer, I get negative 5x. And when I put them together, I get negative 9x. So hot diggity dog. On that, you can make sure that I have positive 10, and I do. So I'm going to put that over here. X minus 2, 2x minus 5. And then things that are in the top will reduce out, will simplify out with things that are exactly in the bottom, like this trinomial and this trinomial are exactly the same. And when you divide these with one another, when I divide these with one another, I get 1. And the same here. When I divide these, I get 1. So you can just put a line like that, or you don't want to scrape it out so hard that people can't see what you had underneath, but 1. And so left over, right, I scraped this out. I scraped this out and got 1. Left over is 1 in the denominator, right? Everything in the denominator reduced out. So I have x plus 3 only left. So that's my answer. So we did a lovely job on that. That's number 14. Number 15, we're asked to add these. In order to add them, you have to have the same denominator. And so we're working on getting a common denominator. In order to get a common denominator, you have to factor the pieces. So this is a difference of squares, x plus 4, x minus 4. This factors 4 times 5 and adds to make 9. So this is x plus 4, x plus 5. And we have the jealous neighbors, right? They agree that, oh, we both have a fountain of x plus 4. But this jealous neighbor looks over there and says, but you have a x plus 5 and I don't have the x plus 5. So we want to give it the x plus 5 by multiplying top and bottom by x plus 5. I almost don't have enough room to write that. So in the numerator here, I'm going to get 2x times x, 2x times 5, right? And the denominator is going to be this whole thing. Jealous neighbors though, right? They both agree we have an x plus 4. And now we both have an x plus 5. But me, I don't have an x minus 4. So I need an x minus 4 over x minus 4. Now the denominators are the same, right? And I'm going to add the numerators together. But order of operations, before you can add this with anything, right? Just look at it. 2x times x plus 5 plus 3x minus 1 times x minus 4. How can you add those together? That's what I need to do next without multiplying them. You have to multiply them so that you can, then you'll be able to combine like terms. So I have the same denominator, right? X plus 4. I'm not going to lose my denominator, x minus 4, x plus 5. So this is 2x squared, whether you write it here or here, it doesn't matter. I was worried about room, so 2x squared plus 10x. I have to FOIL this, but it's plus, so I don't even have to be careful because it's plus. If it was minus, I'd have to be careful because I'd have to FOIL it and then distribute a negative. And so because it's plus, I can just FOIL it together. It's going to be okay. So I'm going to have 3x squared minus 12x minus 1x plus 4 all over the common denominator. And combining like terms, I have 5x squared. I have 10x, take away 12x is negative 2x, minus another one is negative 3x, and plus 4. There's no like terms with the plus 4, right? Plus 4. Over the common denominator. I don't want to multiply the denominator together, because if I multiplied it together, which I certainly could, but then right now I would say what I need to do is factor a factor. And if I multiplied it together, I would be chasing my tail from where I need it. And so you notice that once I made them the same, I just drug the denominator along. And so there was no reason to multiply it together. So I'm on factor. So all I have to do is factor the top. So I'm up here in my, seeing if it will factor. I'm up here off the screen, seeing if it will factor. So x times 5x, only possibility, 1 times 4 and 2 times 2. The signs are both the same, they're both negative. And I want it to add up to be 3 in the center. And I just don't think that's going to be possible, that it's going to add up to 3 in the center. Because I think everything I make is going to be bigger than 3, right? And it needed to add up to 3 in the center. So negative 3 in fact. But like if I have x here and I have 5x here, and my signs, remember, are both negative, and it doesn't matter if I put the 2 here and the 2 here, then I'm going to have negative 10x, and I'm already beyond 3x. And I'm going to have minus 2x, and now I have minus 12x. It just got worse, right? So I have to make numbers that are smaller than 3 and add up to 3. But because I have a 5x up here that has to go in the first spot, I don't think that's going to be possible for me to get numbers, both numbers to be under 3. So anyway, so this is just done. This is subtracting, but the denominators are already the same. So that's nice that the denominators are the same. I'm grateful for that. So when I subtract here, I have to distribute that negative, and there's parentheses implied around that numerator of the fraction. So this is 5x minus 8, and then distributing the negative is negative 4x plus 5 all over that common denominator, x squared minus 10x plus 21. If you factored this already, that's fine, because after I combine like terms, I'm going to say, well, I got to factor, so I can reduce it. And so whether you factor right now or you factor in a minute, doesn't really matter. So I get x minus 3 in the numerator. And when I factor here, making 21 but adding to 10 is 3 and 7, both negative. So in the denominator, factors to be x minus 3, x minus 7. And you notice that when you divide out, the x minus 3 divides out with the x minus 3, leaving us 1 in our numerator and x minus 7 in our denominator. And if you're saying, now I just thought the answer was going to be x minus 7, and isn't that just like the one that you did over here, number 14, where you didn't write the 1? Well, the 1 was in the denominator, and I don't have to write a 1 in the denominator of a fraction, right? But I do have to write a 1 if it occurs in the numerator here. Sometimes people are like, well, I don't understand why. Why are they different? Well, you know that 2 is different than 1/2, right? And this is just not writing the 1, right? And so if I just wrote x minus 7, then it would be the same as me writing like 2 when it was supposed to be 1 over 2. And so they are different from one another. So if you don't believe me, bring me $2 and I will give you 50 cents. So to show you that they are different from one another, they're not an even trade. Okay, so 3 minus 1 over x plus 3, and then divided by 3 plus 1 over x plus 3. So this is a complex rational expression, and I'm going to clear the fraction by multiplying by x plus 3, and I have only x plus 3 as my denominators. So I kind of have these pieces. I have 3 minus 1 over x plus 3, and I'm just going to kind of put these, I like to kind of put them in a box. Put them in a box. Maybe move this over to have my box be a little bigger, right? Because what am I going to be multiplying by? By this denominator, x plus 3, x plus 3, x plus 3. And down here as well. So here's my box, right? What am I going to multiply by? X plus 3. And it's plus, and then 1 over x plus 3 times x plus 3. This is x plus 3 over 1, just the same as this was x plus 3 over 1. And this x plus 3 and this x plus 3 cancel, and so did this one and this one. Those don't cancel, those multiply. So I'm going to get 3x plus 9 minus, and then this is 1. And this is going to be 3x plus 9, and this is going to be plus 1. So this is going to be 3x plus 8 divided by 3x plus 10. And these will only reduce with one another. I've cleared the fraction now. And they'll only reduce with one another if I can factor them, because it's a binomial, using greatest common factor, difference of squares, or cube, right? I'm sorry, I need to get a little sweatshirt. But that won't factor, and neither will that. And so, since they won't factor, they're not exactly the same. There are, it's all done. When I started off, it wasn't cold. And now, in my house, it is cold. I got cold, so I had to go get a sweatshirt. And so this is all done. The top won't factor, the bottom won't factor, so it won't reduce. I'm on 18. It's asking me to solve. And so I notice I have denominators I'm trying to solve. So I'm going to clear the fraction by multiplying by the common denominator. And that common denominator is 3x. These won't factor with one another. So I'm going to multiply every piece, the 1 over x, by 3x, the 3 by 3x, and the 4/3 by 3x, all of them by 3x. And yes, that's 3x over 1. And I'm here to cancel the x's. That's why I multiplied by 3x, because I knew the x would cancel with that x there and leave just 3. So here I get 3. Here, no canceling, so plus 9x. Here, over 1, right? And in this box, I'm going to get some, I got this box here too, right? The pieces, all of them got multiplied by 3x. The 3 cancels with the 3 and leaves 4x. No fraction. So it was rational. And anytime you have rational, you should check at the end, right? So it was rational, and now I'm looking at it and I'm like, oh, it's linear now. Now that I have cleared the fraction, it is linear. And what you want to do is you want to get them separated when it's linear. So I'm going to take away 9x. And that's going to give me 3 equals, right? Because this makes 0. So 3 equals negative 5x. I'm going to divide by negative 5. So my answer is that x is negative 3/5. And that negative can go out to the side if I like. And I can also write it as x equals negative 3/5. I can write the x on the left-hand side. It doesn't matter. Now I want to check my answer to make sure that it works, because anytime that you have a rational, you have to check, because you can get extraneous solution. So this is 1 over negative 3/5. That's what x is. Plus 3 equals, question mark, I'm questioning, does that equal 4/3? And it's certainly okay to use a calculator, which I told you guys that I didn't have with me. So since I don't have a calculator with me, I'm going to do it by hand, but you can put it with your calculator. This is 1 divided by negative 3/5, which is the same as 1 times negative 5/3. So 1 times negative 5/3 is negative 5/3 plus 3. And I have to get a common denominator, 3 over 1, so timesing by 3 at the bottom, 3 at the top, so I get negative 5 over 3 plus 9 over 3. And when I add those together, I get 4 over 3 equals 4 over 3. And I'm like, oh, hot diggity dog. And so I'm happy about that, because that means that there was no mistake when I solved it. It worked out. And of course, I check often with my calculator, and you may check with your calculator or with your head like I did. Either way, people say, I don't want to check. Do I have to check? And the answer is, then you'll likely get them wrong if you don't check. And so all things being equal. So here I'm trying to solve this one. And so in order to find the common denominator, I want to factor the denominators. And so then I can clear it by multiplying by that common denominator. So I'm going to factor the denominators, x plus 2. This denominator underneath here is x times x minus 1 minus, and then this denominator is a difference of squares, x plus 1, x minus 1, and then equals 0. And I'm going to build the common denominator, the lowest common denominator. This one says it's got to have an x and an x minus 1. So x and an x minus 1, there they are, as its factors. This says it's got to have an x plus 1 and an x minus 1. Well, it already has an x minus 1, so all it needs more is an x plus 1, and I'm building the common denominator. So there is the common denominator, and I'm going to multiply this common denominator that has 3 terms by this term and this term and that term. I'm going to do it to all of my pieces. So I'm going to multiply this term, x plus 2, over x times x minus 1. I'm going to multiply it, remember this is in the numerator, by x times x minus 1 times x plus 1 over 1. And I'm going to do it to this one as well. 6 over x plus 1 x minus 1. And you do get where you can see kind of what's going to happen, and you don't feel as unconfident as you write it out. You feel like, oh, this is good, I'll write this out. Equals 0 times, and then same thing, multiply it by x times x minus 1 times x plus 1. And I'm here to cancel, and an x reduces out with an x, and an x minus 1 reduces out with a x minus 1, and leaves me left over an x plus 2 times an x plus 1. So x plus 2. Now you might be saying, but there weren't parentheses around that. Well, they're implied around every numerator of every fraction and every denominator. And so, and then minus 6. So let's see what we're going to have. The x minus plus 1 and the x minus 1 are going to reduce out, and it's going to leave the minus 6 times x. And then over there, I thought it was going to be a mess. I was like, oh goodness, but 0 times this is 0. So it was kind that it was 0. So now I don't know, it was rational. So right here it was rational, which means check your answer at the end. You know, clear the fractions. I went and did it. Now I'm looking at it and I'm saying, well, is this linear or is this quadratic? Well, I don't know because this is involved in a multiplication, but I'm suspecting highly that when I multiply this together, it's going to be quadratic. So x times x is x squared. So I'm foiling plus x plus 2x plus 2 minus 6x equals 0. And now I'm sure, yeah, it's quadratic. And so in order to solve something that's quadratic, what you need to do is get 0 on one side, which I have, and you have to put the other side in descending order, which I haven't done. So I have right here 3x minus 6x is positive 3x, so this is x squared plus 3x plus 2 equals 0. So now it's in descending order with 0 on one side. So you're ready for the next step of solving a quadratic, which is to whip out the F word and factor it. 2 times 1, which does add to 3. So that's hot diggity dog. So this is x plus 2, x plus 1 equals 0. So we're going to have x plus 2 equals 0, and x plus 1 equals 0. And so we're going to get negative 2 as one of the answers. And we're going to get negative 1 as the other answer. And you need to check them both. Remember, when it was rational, you need to check. Must check. Must check. Anything that makes your denominator 0 of your original is not a good solution. So here's my original, x plus 2, right? Whatever plus 2, whatever you say the answer is, over the whatever squared minus the whatever minus 6 times the whatever minus 1, right? Whatever squared minus 1 equals 0. And if I check x is negative 2, and I put in here negative 2, negative 2, negative 2, negative 2, and you can do that by hand if you like. That would be marvelous if you wanted to do that by hand. So I get here in the numerator, I get 0. And down here in the denominator, I'm going to get 4 plus 2 is 6. So this is 0 over 6 minus 6 over, I made a boo-boo somewhere, because this is not undefined. This is 3, and this is not true, right? This is not equal to 0. So let me see if I can find my boo-boo. Oh, that was negative 3 right there. right? It was 3x minus 6x is negative 3x. So I knew, hey, this is not working. So I'm going to erase that because it wasn't true, right? If it's not true, you made a boo-boo. So I started looking for it. You probably could see that I was starting to panic, that it wasn't working out. And here's my boo-boo. This was a minus, right? When I put those together, I said it was 3x positive, but it wasn't. It should have been minus. And that changed. That changes everything, but not a lot. Changes my signs, but I'm going to erase anyway because I feel like I'll probably mess it up if I don't. Everybody makes mistakes. Even if they've been doing a lot of math, they've been practicing a lot, you still make mistakes. So I get x minus 2 equals 0, but people that check their work get to fix their mistakes, whereas people who don't check their work don't get to fix their mistakes. Sometimes people say, well, what if I just checked in the back of the book? And so then you don't have the learning of checking your work. And when you get your first job, you'll be a person that doesn't check your work. You just think your work is always just right. And you'll have a lot of little boo-boos. So it's a good idea to check. So x is 2 now. So I have the blank plus 2 over the blank squared minus the blank minus 6 over the blank squared minus 1 equals 0. And I'm putting in 2. So now when the dust clears here, I have 4, and this is 4, take away 2 is 2. So this is 4 over 2, and you can do this with your calculator. Down here in the denominator is 1, so this is minus 6. Oh shoot, that's still not going to be true. Oh, down in the denominator is 3, thank goodness. Sorry, I said the denominator was 1, but if I was using my calculator, I would know this is 4, take away 1 is 3. So I have 2, take away 2, hot diggity dog. Almost had another boo-boo there. I'm asking myself, question mark, is this true? Okay, so x is 2 is a good solution. Nothing wrong with it. When I go to check x is 1, though, back in the original, checking x is 1, remember it's a blank plus 2 over the blank squared minus the blank. And when I put in 1 here, and I put in 1 here, and I put 1 here, now I'm going to have to also do it with this over here as well. But if any place is 0 in the denominator, that's not allowed. And see how this denominator is 0? This is 3 over 0. And so right there, this is an extraneous solution, which means it's not really a solution. So we're going to cross it out. And so your back of the book will say there was an extraneous solution of 1 because they want you to know that that wasn't really a solution and that you weren't just crazy, that you thought 1 was a solution. And they're saying, go check it, it doesn't work because it makes the denominator 0, which is not allowed. If it makes one denominator 0, it's not allowed. It doesn't matter if it makes them all 0 or just one of them. And in this case, it was just one of them. Last question is, after a football game, Donna can clean the whole stadium in 100 hours. She is a really very slow worker. She's very slow because she is constantly looking at her phone. Doug is a much harder worker. He can clean the whole stadium in 20 hours. President Sonia needs the stadium cleaned fast. And presumably, she needs it cleaned faster than 20 hours. Otherwise, she'd just hire Doug. So she hires both Doug and Donna to clean the stadium. About how long will it take them working together to clean the whole stadium? Write your answer as a mixed number. So we have a formula for when people are working together, and that formula is T over A plus T over B equals 1 job done, where T stands for the time that they work together, and A stands for the time that one of them works together. In this case, we have Donna and Doug, so this is the time for Donna. It doesn't matter which one. And this is the time that it would take Doug if he did the stadium all by himself, right? And this is the time together, T's right there, time together. I'm glad I'm getting this done because I have a class that is going to start in 15 minutes. So hot diggity dog for me. So I have a class that starts at 7, and I'm just going to barely get this done. So I'm glad. So this is T over, and then Donna's time was 100 hours. And T over, and Doug's time was 20 hours. And 1 job done. And then I just have to solve that, and the common denominator is 100. And so I'm going to use the common denominator to clear the fraction. And so I'm going to multiply, because I notice it's rational. I'm going to multiply by 100 to clear the fraction. It's rational. And so when I multiply by 100, T over 100 is nice. The hundreds cancel and just leave T. And when I multiply by 100 times T over 20, 20 goes into 100 5 times, and so this gives 5T equals 1. 1 job done. Oh, times all of them by 100, right? So I need to times this also by 100. Whoops, I almost boofed that up. In my excitement to almost get it done in time to go to my class, 1T plus 5T is 6T equals 100. And so T equals, I'm going to divide by 6, equals 100 over 6, which is the same as 50 over 3. And they asked us to write it as a mixed number, and this is an improper fraction, and this is in hours. And they asked us to write it as a mixed number, so you could use your calculator or long divide. Do it by hand, long dividing. So this is a 3, remainder 2, 0, and this goes in here 18 times, right? 3 times 6 is 18. That's what I was trying to say, 18. And remainder 2. And so this is 16 and 2/3 hours. So if we work together, we can get the stadium all cleaned up in 16 and 2/3 hours. So remember, I was very slow, and I was always looking at my cell phone. So I wasn't much help. I only cut Doug's time down by not even 4 hours, right? So he could have done it all by himself in 20 hours, but having me help, you know, got it cut down a little bit, shaved a little bit of time off of it. But maybe there was a football game, and then immediately after there was a cheering competition or something like that. I don't know. And they needed the stadium all cleaned up. Okay, so that's Lab 41, and I'm gonna go to my other class and upload this to YouTube. Stop recording.